Okay, now we're going to learn how to change from standard form to vertex form, just in case we want it in this other form. We've talked about both forms now. Standard form is y equals ax squared plus bx plus c, and then in vertex form, you can actually see those transformations. So we're actually going to go back and review some algebra. We're going to use some algebra 1, some basic algebra, to change from one form to the other form. So here we go. Here's what we do. Let's remind you on what a perfect square trinomial looks like. What I mean by a perfect square trinomial, a perfect square trinomial is any trinomial that when you factor it, like x squared plus 6x plus 9, when it gets factored, two sets of parentheses, what multiplies give you x squared to be x and x, what adds to give you 6, multiplies give you 9 to be a positive 3 and a positive 3. You notice you get the same thing twice. So that'd be x plus 3 times x plus 3 or x plus 3 to the second. That's a perfect square trinomial. So how do we recognize it from the original form, ax squared plus bx plus c? If you can take half of this b, or we can write that as b divided by 2, either way. If you can take half of b and square it, and it's equal to the exact same thing as a times c, then you have a perfect square trinomial. Like, let's see here. If I'm able to take half of b, which is 4, and square it, does it equal the same thing as 1 times 16? And yes, it does. So when we factor this, it should be a perfect square trinomial. So two sets of parentheses, if you would like to. What multiplies give you x squared to be x and x. Adds to give you 8, multiplies give you 16 to be a positive 4 and a positive 4, which we can write as x plus 4 to the second power. You can check this. Take half of the 2, you get 1. Multiply it times itself. 1 to the second power, you get 1. Is it the same thing as 1 times 1? Yes. So when we multiply, or when we factor, we should get a perfect square. A times a gives you a squared. Adds to give you 2, multiplies to give you 1, be a positive 1 and a positive 1, which we can just write as a plus 1 to the second power. Half of negative 18 is negative 9. When you square it, it gives you 81, which is 1 times 81. It does check out. So instead of writing it twice, we can just write it once because we know it's going to be a perfect square. Multiplies give you m squared to be an m times an m. Adds to give you negative 18. Multiplies give you a positive 81 to be a negative 9 and a negative 9. Half of negative 10 is negative 5. When you square it, it gives you 25. Is that the same as 1 times 25? Yes, this is a perfect square. Two sets of parentheses, or 1 squared. P times P gives you the P squared. Adds to give you negative 10. Multiplies to give you a positive 25 would be a negative 5 and a negative 5. Now, when you know that something's a perfect square, since it has to add to give you the middle term, in order to factor it, you can actually just take half of it. Remember that as we go through these. So here's our steps. How do I change from standard form to vertex form? By using this perfect square trinomial stuff. It says if the standard form of an equation is a perfect square, like the example of example 1, simply factor to convert the forms. If not, you can use a process called completing the square. So the example 1 down here, we're already going to have a perfect square, but if not, we're going to have to somehow make it a perfect square. Now, I do it a little bit different from these directions. Okay, I am going to group ax squared plus bx, but step number 2, well, we're still going to have to do this. If there's a number in front of the x squared, I am going to factor it out. Okay, we're going to complete the square like in step 3, but I do something else in there. I'm going to move my constant term somewhere between, actually you can do it to begin with. I'm going to move my constant term from one side to the other side. I'm going to go through the process like it says here, but instead of subtracting AC, I'm going to do things a little bit different. So let's go through my steps of how I change this. Well, first off, instead of f of x, instead of having to write f of x every time, I'm going to put a y. So y equals x squared plus 4x plus 4. Step number 1, I take my constant term and I move it to the other side. So I now have y minus 4 equals x squared plus 4x. What I do now is I take what's left. If there's a number in front of the x squared, it does have to be factored out. But I take what's left and I complete this square. Now let's talk about what I mean by completing the square. Those perfect squares like we talked about up here. I need perfect squares. I need somehow to make what I've got over here a perfect square. Now in this case, it was already a perfect square, and kind of what we're doing now is defeating the purpose. But what could I add to this to make this a perfect square? Well, how do I figure that out? It's a perfect square. Remember what I said? If you can take half of your b term and square it, and it's going to equal the same thing as a times c, which in this case my a is 1. So pretty much I'm going to take half of this middle term and I'm going to square it. And that's how you complete the square. And that tells you what you're going to add. So take half of this 4, that's 2, square it, and it gives you 4. That should now be a perfect square, but that's not legal. You can't just add 4 for no reason unless you do this. It's an equation. If you add 4 to one side, the additive, the property, the addition property of equality says if you add 4 to one side, it's legal as long as you add 4 to both sides. So if you add that 4 to complete the square, let's do it to both sides. Clean up this side, which it actually cancels, and it leaves you with y equals. Once you complete the square here, we're now going to factor. Every time you complete the square, you always follow up by factoring. This should be a perfect square. So you can do 2 sets of parentheses if you would like. X times x gives you the x squared. What adds give you 4 and multiplies give you 4 be a positive 2 and a positive 2. It is a perfect square. So instead of writing it as x plus 2 times x plus 2, let's write it as x plus 2 squared. You have now converted y equals x squared plus 4x plus 4 into vertex form. And that's it. It says also give the vertex. So this moves it. You have a plus 0 tacked on to the end. So your vertex got moved left 2, up 0. So from the previous lessons, your vertex would be negative 2, 0. Number 2. Now we can do a little bit better work with this because this is not a perfect square. I should have checked on that last one, which even though they told us, I forgot. But you can always check. You can take half of this, square it, and if that's equal to a times c, again, that was the rule that we did up front, then it's a perfect square. This is not a perfect square trinomial, so we are going to have to go through the steps. Step number 1, move the plus 18 to the other side. Step number 2, we're going to complete the square on the right side. If there's a number in front of x squared, we are going to factor that out. Or you can just use the trick that I showed you first. You can take half of b and square it, and it should equal to a times c. You can do it either way. So what would complete this square? Take half of negative 8, multiply it times itself. That's what would complete this square, 16. Because again, if you check it, half of b squared is equal to a times c. It does check out. However, it's not legal to add 16 to one side unless you add it to both sides. So on the left side, we now have y minus 2. On the right side, this should factor into a perfect square. X times x gives you x squared. What adds to give you negative 8, multiplies give you 16, would be a negative 4 and a negative 4. So that does factor into x minus 4 squared. The last step, this minus 2, I'm now going to move it back to the other side, and you have y equals x minus 4 squared plus 2. That is now in vertex form. So you went from, again, standard form to vertex form. What is the vertex? The vertex is found right here. It got moved right 4. If you remember your transformations, right 4 and up 2. So right 4 and up 2. Your vertex is now at 4, 2. Now, could I take this and use the whole x equals negative b over 2a, b is negative 8, so that'd be 8 over 1 is a, 8 over 2, you get 4. Would it give you the exact same answer? Yes, it would. Number 3, move the negative 5 first. Again, I'm going to write this as y equals, so I'm going to go ahead and move my 5 over by doing plus 5. Now this one's a little bit different. If there is a value in front of x squared other than 1, it needs to be factored out. So what you've got to do in this next step, y plus 5 equals, there is a negative 1 in front of that x squared. Factor the negative 1 out of the entire term, or entire expression. Negative 1 times x squared gives you negative x squared. Negative 1 times a negative 6x gives you a positive 6x like and above. Now what we're going to do is we're going to complete this square, the stuff inside of parentheses. How do I do that? You take half of negative 6 and you square it, and you get a positive 9. Now, however, this is the tricky part. On the right side, yes, you added 9 inside of parentheses, but what did you add to the whole side? Look, there's a -1 on the outside. If you were to distribute that back out, do you understand that -1 times that +9 would actually equal -9? So technically, what did you do to the right side? You subtracted 9. You did -1 times 9, which is a -9. So since that's what you did on the right, make sure you do that exact same thing on the left. On the left side, you have +5 and -9 is a -4. Bring down the -1 in front of parentheses that you factored out. Inside of parentheses, this stuff should now factor into a perfect square. X times x gives you the x squared. Adds to give you -6, multiplies to give you a +9 would be a -3 and a -3. Move the 4 back over, and it gives you y equals negative parentheses x minus 3 squared plus 4. There's vertex form. Here's your vertex. Your vertex, you moved right 3 and up 4 with transformation, so there's your vertex. Number 4, we'll work several of these problems because, again, these are a little bit more difficult than some of the stuff that we've been doing. Again, step 1, we always move our constant over. So you now have y minus 13 equals 2x squared minus 12x. If there's a number in front of x squared, it now gets factored out. So we do 2 parentheses. 2 times x squared gives you 2x squared. 2 times -6x gives you -12x. Inside of parentheses, we're going to complete the square. To complete the square, you take your b term, take half of it, and square it. That's the value you're going to add to that side. However, once again, we added 9 inside of parentheses. Anytime you have those parentheses, you've got to be careful about what's out on the outside. Yes, you added 9 on the inside, but if you were to distribute this back out, you actually added 2 times 9 to this whole side. So make sure that you add 2 times 9 to the other side as well. 9 was added inside parentheses. 2 times 9 was added to the whole side. So -13 and 18 gives you a +5. Bring down the 2 and factor. Anytime you complete the square, you're always going to factor right after. And since you completed a square, this should factor into a perfect square. X times x gives you x squared. What adds to give you -6, multiplies to give you a +9 would be a -3 and a -3. If you don't get a perfect square, then it was not done correctly. Last step, move the 5 back over, gives you y equals 2 parentheses x minus 3 squared minus 5. Make sure you change signs when you move it back over. Your vertex can be found here. Your vertex got shifted right 3, the opposite, and down 5. So your vertex is at 3, -5. Number 5. Now this one's going to be a little bit tougher because you're going to have to take half of that, and you're going to have to square it. So that's a little bit uglier. So first step, we're going to have to move the -2 by adding 2. You have x squared minus 3x. Now, if there's a number in front, we do have to factor it, but since there's no number out front, we don't have to worry about factoring. Now, to complete the square, let me draw me a blank here. To complete the square, we've got to take half of -3. Now, here's how I want you to do it. Let's not take half of -3 and write it as a decimal. Let's take half of -3 by simply dividing by 2. Because I told you a trick in some of your other lessons, and so let's see if we remember this. If we have a fraction, and we need to square a fraction. Okay, I have took half of -3 by dividing by 2, and now it's -3 halves. To square a fraction, you simply square the top and square the bottom. It's going to make it a whole lot easier. First off, a negative times a negative is a positive. Square 3, square 2. You get a positive 9/4. So we're going to add 9/4 to both sides. I didn't have to worry about anything being factored out and multiplied by both sides. I simply added 9/4 to the right side. Okay, in order to combine these, I need some common denominators. So I've got to do 2 over 1 plus 9 over 4. Common denominator is going to be 4. Let's multiply top and bottom by 4. It gives me an 8 over 4. So I now have y plus 17 over 4 equals. Let's factor the right side. It's going to be a perfect square. X times x. Now, this is a little bit trickier. What in the world adds to give me a -3 and multiplies to give you a 9/4? Actually, the answer is right in front of you. What adds to give me -3? Well, didn't You just half -3. If you half something and then you go back and double it again, do you not get the original back? So if you were to add -3 halves and -3 halves, that would give you -3. And what multiplies, so not only that, but I'm asking myself what multiplies to give you 9/4? Well, we did it right here. -3 halves times -3 halves was 9/4. So when we go to factor this, the easy way, now that you have it, the square completed, it will always factor into whatever half of that was. Because again, that added to itself would give you this, because it's half of it. And that multiplied by itself would give you this, because that's actually how we found that number. So there it is factored. Move the 17/4 back over, and it gives you y equals x minus 3 halves squared minus 17/4. Now that's a pretty ugly vertex form there, but your vertex is easy to find. This moves it right 3 halves. This would move it down 17/4. So there's your vertex. Number 6. You have y. Let's go ahead and move the minus 22 over. Equals negative x squared minus 9x. If there is a value in front of x squared, it has to be factored out before you begin. So y plus 22, let's factor out the negative. You're left with an x squared, because negative 1 times x squared gives you negative x squared. Negative 1 times a positive 9x would give you a negative 9x. And let's leave some space in there, because now that I have it factored, now I have to complete the square. So again, to complete the square, I'm going to take my 9. I'm going to take half of it by dividing by 2, and I'm going to simply square it, and I get a positive 81/4. That's what you're going to add to both sides. However, to the right side, if you look, again, I factor out this negative 1. Parentheses. If you were to factor or multiply this back out, to the right side, you actually added a negative 81/4 when you distribute that back out. So make sure you do the same thing to the other side. Add a negative 81/4. Okay, we've got to combine a positive 22 minus an 81/4 to get this answer right here. I need a common denominator, so I'm going to multiply top and bottom by 4. Gives me an 88/4 minus 81/4, which would be a 7/4. So on the right side, I now have y plus 7/4. Let me erase this because it's kind of in the way now. And on the right side, I bring down my negative 1, and I've got to factor the stuff inside of parentheses. It's a perfect square. X times x gives you the x squared, and now it should be really easy to factor these. What adds to give you 9, multiplies to give you 81/4. You just did it. A positive 9 halves. So pretty much, again, you can just take half of that, and that's all what it's always going to factor into. Move the 7/4 back over, leave the negative, and I'm going to take the 1 away just because it's understood to be there. And here's what you get. So therefore, my vertex is here, here. Left 9 halves, down 7/4. Number 7. Okay, this one doesn't have a c term, so it actually makes it a little bit easier. Nothing has to be moved over. So I have y equals x squared plus 5x. I've got to complete that square. I don't have to factor anything out, so we're good there. To complete it, I'm going to take my 5. I'm going to take half of it. Since it's odd, I'm going to leave it as 5 halves, and I'm going to square it. So a positive 25/4 is what I'm going to add. If you're going to add 25/4 to one side, make sure you add it to both sides. Those won't combine, so I'm going to leave that as y plus 25/4 equals, let's factor the right side. Should be a perfect square. X times x gives you your x squared. What adds to give you 5, multiplies to give you 25/4. That's going to be 5 halves. Again, just take half of this. Move the 25/4 back over, and you're finished. Y equals x plus 5 halves squared minus 25/4. So your vertex is going to be left 5 halves and then down 25/4. So a little bit uglier, again, uglier vertexes than what we're used to. Number 8, nothing's being added. There's no C term out here, so there's nothing that I need to move over. So I now have y equals, but however, there is a number in front of x squared. Let's factor that out first. 4 parentheses, x squared minus 2x. Leave you a blank. The reason I leave the blank is because I now have to complete the square. This one would be easy. Take half of the b term and square it. Negative 2 divided by 2, half of that would be negative 1. When you square it, it gives you a positive 1. So we're adding a positive 1. But again, you got to be careful. Even though you added a positive 1 inside of parentheses, since there's a 4 out here, you actually added 4 times positive 1 to this side. So we're going to add 4 times positive 1 to the other side as well. You now have y plus 4 equals 4 parentheses. You completed this square, so that should be a perfect square trinomial. X times x gives you x squared. What adds to give you negative 2, multiplies to give you positive 1. Again, is simply half of this. Move the 4 back over and you're finished. Y equals 4 parentheses. X minus 1 squared, and the plus 4 turns back into minus 4, and there's your vertex form. Your vertex would be here and here. Well, right 1, so that'd be positive 1, and down 4, so 1, negative 4 is your vertex. Number 9. Step number 1, move your minus 46 over by adding 46. Oops, I'm getting ahead of myself. That'd be negative 2x squared plus 20x. If there is a value in front of the x squared, it has to be factored. So let's factor out a negative 2, and you're left with x squared minus 10x. Leave yourself a space because we're going to complete the square. Take half of negative 10, and you can do that in your head. That'd be negative 5. Square it, and you get a positive 25. Ask yourself, is that what we added to the side, or is that just what we added inside parentheses? And there is a number outside of parentheses, so technically we added 25 inside parentheses, but we added negative 2 times 25 to that side. Negative 2 times 25 is negative 50, so therefore you have to add a negative 50 to the other side as well. That turns this into y minus 4 equals, bring down negative 2, and let's factor. X times x gives you x squared. Adds to give you negative 10, multiplies to give you 25 would be a negative 5 and a negative 5. Move the 4 back over and you are done. Negative 2 parentheses x minus 5 squared plus 4. There's vertex form. Here is your vertex located right 5 and up 4 from where it used to be. So there the vertex is at 5, 4. And the last one of these looks horrible. Step number 1, move your minus 5 over by adding 5. We're going to follow the exact same steps. Negative 1/2 x squared minus 4x. If there's a number in front of x squared, it must be factored out. And we're not used to factoring out fractions, but it's very simple. So we're going to factor out a negative 1/2. What are we left with inside of parentheses? So we've got to ask ourselves, negative 1/2 times what gave me this term? That one's easy. But negative 1/2 times what gave me this term? A negative times a positive would give you the negative. But 1/2 times what gave you 4? Again, remember that 1/2 times something is the same thing as 1/2 of something. So 1/2 of 8x would give you 4x. So now it's pretty simple, right? So now let's complete our square. Take half and square it, and you get a positive 16. However, you added positive 16 inside parentheses, but you added negative 1/2 times positive 16 to that side. Negative half of 16 is negative 8 is actually what got added to the side. Combine like terms, positive 5, negative 8 is a negative 3. Bring down your negative 1/2 and let's factor. X times x gives you x squared. What adds, what multiplies will always be half of that would be plus 4. And you're finished. Move the 3 back over. Y equals negative 1/2 parentheses x plus 4 squared plus 3. So your vertex is here. Your vertex got moved from the original spot, left 4 and up 3. There's vertex form, and there is your vertex. Okay, on the next problems, it says convert to vertex form, identify the vertex, axis of symmetry, and then we're going to graph this. Now, we've actually got other ways of doing this. We could find our axis of symmetry since it's in this form by using negative b over 2a, and I just want to show you that both ways work. Negative b over 2a would be 12 over 2, which is 6. And you could fill that in to find the vertex, which would be 6 comma. When you plug it in, you should get 3. So your vertex is going to be 6, 3. However, we've got a new method. Okay, and let's go through that new method again. So you have y, we're going to move our plus 39 over by subtracting 39, equals x squared minus 12x. We're going to complete our square, and it's really easy. These are whenever this is a 1 and whenever your b term is even, it makes these problems pretty easy. Half and times itself. That'd be negative 6 squared, which is a positive 36. Make sure you add it to both sides. You now have y minus 3 equals, we're going to factor, should be a perfect square. X times x is x squared. The rest of it should be half of that negative 12, which is negative 6. Move the 3 back over. It gives you y equals x minus 6 squared plus 3. So there it is in vertex form. Now let's look at what we got over here. My vertex from the other method was 6, 3. So you get the exact same vertex regardless of how you work it. So we're going to put 6 here, 3 here. To find other points on our graph, we can plug in 5, 4, and 3. We can plug in 7, 8, and 9. It should be symmetrical. And you can kind of pick which one you'd rather plug it into. Usually this is going to be easier. So let me copy this back down over here. Y equals x minus 6 squared plus 3. Let's plug these points into it, and then we'll plot them on our graph. We can go ahead and plot our vertex. 1, 2, 3, 4, 5, 6, 3. So our vertex is located here. This parabola should cup up. Let's plug these values in and see what we get. And there's what you get. And a reminder, it doesn't matter which form you plugged it in. If you plugged it into this here, you would have got the exact same values. Plotting your points and then connecting your dots, there's your parabola. Okay, one last one. We're gonna write this in vertex form, and again, you can use negative b over 2a if you would like to. You're going to come up with the exact same answers. Step number 1, move the minus 8 over by adding 8. If you would like to, you could go ahead and factor in this same step, but if there is a number in front of x squared, it must be factored out. So we're going to take y plus 8, factor out the negative 3. Negative 3 times x squared gives you negative 3x squared. Negative 3 times a positive 4x is equal to a negative 12x. Now, one thing that we've not run into is what if this is a number that doesn't factor out of both of these? And we'll get to those later on. Those will be much more difficult, but they are still doable in this method. Inside parentheses, we're going to complete the square here. We're going to take half of the 4 and multiply times itself. Half of 4 is 2. 2 times 2 is also 4. You added 4 in parentheses, but you added negative 3 times 4 to this side. And that would be a negative 12, which you're going to add to the other side. That turns into y minus 4, bring down negative 3, and let's factor. Anytime you complete the square, you always turn right around and factor. X times x, and 2 and 2. Move the 4 back over, gives you y equals, and I'm going to write this over here so we can graph it easier. Y equals negative 3, parentheses, x plus 2 squared. Move the 4 back over, it turns into plus 4. So there's what we're graphing. Our vertex can be found here. That would be left 2, up 4. We're going to plug in some more values. Let's plug in maybe negative 1, 0, and 1 on this side, negative 3, negative 4, and negative 5 on the other side. When you do plug those in, here's what you get. And then we're going to plot those on our graph, and let's connect our dots. And there you go. Now, a couple of reminders here. Since this was a negative value, that's the reason it's upside down. The larger this number gets, the skinnier your parabola gets. If it's a fraction, it's going to be wider and fatter. This again was the transformation that found your vertex for you, and that's it.